Hi, in this video, we are going to see time series analysis using SQL. Now, I'm going to take through some simple SQL statements for time series analysis, and then gradually we will move on to some complex SQL statements. For this purpose, I'm going to use Google BigQuery, but you can use any SQL database and with any data set. The queries I'm going to show is pretty much customizable for any data set and even to non-time series data set. So you can use any SQL databases. It can be Postgres, it can be Oracle, it can be SQL Server. I'm going to use BigQuery over here, which is pretty much ANSI SQL compliant, similar to any other database. So the queries are pretty similar. Only thing is your database might change. I'm using BigQuery for convenience because I work on BigQuery and use BigQuery almost every other day. So I have access to it. I'm using it. So for the purpose of this particular demo, I'm going to use a public data set that is available within BigQuery. It's called New York Taxi data set over here. It is in the BigQuery public data. It's in the New York's taxi trip. And from that, I'm going to pick one table called TLC Green Trips 2018. Pick one data set out of it. And this is how the data set looks like. The data set is basically the taxi trips in New York for this particular green cab, and you can see there's a pickup date time, drop off date time, that is a fare amount, and that is a tip amount. All these columns are there, whatever happens within the trip. And specifically I'm going to select only few columns out of it to show some of the simple to complex SQL statements. So let's get started. So first thing is let's quickly pick only selected column that we need as of now. So what I'm going to do is I'm just going to say select pickup date time, fare amount, and tip amount. So from the schema you saw over here, you have pickup date time, drop off date time. You can also preview the data here. You can see basically the data is up to a second level, so it's an actual second when the trip started, and then you can move on and see that is a fare amount, there's a tip amount, and everything. So what I'm going to do, I'm going to select only few columns that are required. So I'm just doing a select pickup date time, fare amount, and tip amount from this particular data set. And once I run this, you will basically see the results over here. So let me go to the results tab, and then the statement is executing. So it is a pretty large data set over here. So if you go to the data tab and view details, you can see it's around 1.44 GB data set. It's a pretty large data set, and it has close to 8.8 million rows. Okay, now this is how the data looks like. So basically you have the date, you have the fare amount and tip amount. Tip amount looks that is zeros. There are actual values that the customer actually paid tip. Okay, so this is the data set we are going to use. The very first query I'm going to do is I'm going to basically check. Basically, there are 24 hours in a day, and the New York taxi cab run almost like 24/7. So I want to check which particular hour of the day the maximum fare amount comes from, or the maximum number of trips happens to begin with. So that's what I'm going to check. So I'm going to compose a new query over here, and then I'm going to basically take this particular. I've just copied the old one. Let me copy the new one, this particular query, and run it. So here what I'm doing, if you see our data over here, it is at an particular second level. Right now, I just need to extract the particular hour, whether it was at morning 1 o'clock, 2 o'clock, 3 o'clock. So for that, what I'm doing is I'm just using the extract function. I am extracting hour from this pickup date time column, and I am just giving alias to it as hour, and then I am just doing a count of number of trips. So basically each hour, what is the number of trips it is, and I am grouping it by hour because I'm using like an aggregate function. I'm just grouping it by hour, and then I am just ordering it by the number of trips column descending, so that I can get based on the maximum trip that is based on that is being done at each hour. So when I run this, basically you will see on a hour level between like 0 to 24 hours, what are the trips. So what we can see here, at 6 o'clock, at 5 o'clock in the evening, and even at 7 o'clock in the evening, 4 o'clock in the evening, the number of trips are pretty higher. And if you scroll down, it's a 20, you are just going to get 24 hours data output, because I've aggregated it per hour. And the lowest trip is basically close to around midnight, 10 o'clock, 11 o'clock, 12 o'clock. That's where the lowest trip happens. Number of trip happens. So basically, during the office hours in New York, a lot of people avail car to get back to station or to get back to home, and that's where you can see when they're out of the office at 6 o'clock, 7 o'clock, or 5 o'clock, the number of trips are higher. And during the midtime, there's low usage of cars, and it's lower. So that's what basically you can see over, not 24, I'm sorry, it's the morning, 1 o'clock, 2 o'clock, 3 o'clock. That's where is the lowest, right? 24 is just like a row number. That's where it is lower. So early morning time, it's low. Other times, it's higher, right? So this is, I'm aggregating at an hour level. Now we also next want to see basically which hour do customer pay better tips. All right. Now what I'm going to do, I'm just going to modify this query slightly. Here I'm just doing the same thing, extract, and I'm taking the average of fare amount. So my idea is, basically I want to see what time of the hour when we avail a cab, a customer pay better tip. That's what I want to basically check. So what I'm doing over here, I'm extracting the hour, I'm taking average of fare, the fare amount average, and average of tip amount. So against each fare amount, I will also have a tip amount. And again, I'm grouping by hour. These two are the aggregate columns. Again, I'm grouping by hour. And then I'm just doing an order by tip descending to get the maximum tip amount. So once I run this, basically I'm going to get which hour the tip is higher. So typically the tip is higher during the night time, when it's 10 o'clock, 11 o'clock, and 9 o'clock. That's where the tip amount is higher, and the tip amount gradually decreases. So basically, this is what we see. Now we exactly don't know the percentage of tip amount. We want to know, like, basically what is the percentage of tip given based on the fare amount. That's what we are looking at. So I'm again going to modify this query. I'm going to select again the same column, and based on the fare and tip, I'm going to calculate the percentage. And this is how the modified query looks like. So you have the fare amount and tip amount as the previous query. Now what I'm doing is I'm taking that average tip amount value, and I'm dividing by the fare amount and doing into 100, so that I can get a percentage. I want to know whether they pay 5% per tip, or 6%, or 10% tip, or 15% tip. I'm just looking at average, not at really individual records. I'm doing the same thing, and I'm doing like tip amount descending. So once I run this, I'm going to get what is the actual percentage I'm getting. Now what we can see is during the night time, again, like 10 o'clock, 11 o'clock, and 9 o'clock, the tip is close to around 10%, 9 point, this is also 10%, around 9.5%. And the tip percentage decreases to 6% during the lowest period, right? So basically what we are doing, we're taking a time series data, and we are slicing it by multiple dimensions. In this case, I've just taken hour and doing an analysis at an hour level on what is the various fare amount and what is the various tip amount. That's what I'm doing. Now I did a descending on tip amount, but we can also do descending on basically the percentage as well. We can just change the query to do that. And now first thing what we saw is based on analysis based on hour of the day. Now what I'm going to do, from hour of the day, I'm going to move to the weekday, right? So I'm going to see how does the number of trip looks across the weekday, whether it's Monday, Tuesday, Wednesday, Thursday. How does the trip looks like? Is there any exponential spike during the weekday and lower on the weekend, or is the spike during the weekend or lower on the weekday? That's what I'm going to do analysis. If you typically TSC a time series model, right? That's what we typically do. We typically find a seasonality, whether there's a weekly seasonality or hourly seasonality or monthly seasonality, and that's what I'm trying to do with SQL queries rather charts. Now, most of our data typically lies in a database, and it's easy to just run some SQLs and do some quick analysis before plotting it or using it in Python or other program. Basically, that's what I am trying to do over here. Now, in order for me to get the weekday from the extract of that we saw at our level, what I'm going to do is I'm just going to change that function to format date. and in the format data I'm picking the same date time column and I'm giving percentage a. Percentage a is to pick the weekday. Now if you want more information on what are the other things, you can go into the format date function reference, and you can say percentage a is basically you will get the weekday name. Percentage small a is basically you will get the short form of the weekday name, and similarly you have for month, year, day, and multiple other ISO codes you will have. So that's what I'm doing. I want weekday, so I'm doing percentage a, and I'm counting the number of trips. Earlier we saw on an hour level how is the number of trips. Now I'm seeing at an weekday level how is the number of trips. So that's what it is. But I'm grouping by weekday instead of hour now, because weekday is my granular criteria and count of star is my aggregate to know the number of trips, and I'm ordering by number of trips. So let me run this, and you can see the results. On Saturday the trips are higher, and the Friday the trips are higher. Typically people, it's a New York City, and there are a lot of things to see over the weekend, Saturday. So people just go for as a tourist and over there, and even the Friday night it's like a nightlife city. So after office hours people just go to people just kind of go to a restaurant or go to a bar. So that's what New York life is. So that's what you can see as well. The Saturday and Friday the trip are higher, and Sunday people want to get back to work on the next day, so it has like a lower rights. That's what basically we can see over here. Now, what I'm going to do, I'm going to do the same thing based on weekday, what we did based on hour. I'm going to find the tip amount. Rather at hour level, now I'm going to basically find the tip amount at a weekday level. So I'm doing the same thing. I'm just selecting over here. Let me run this and let me talk about the SQL. So what I'm doing is I am basically selecting the weekday, I'm selecting the fat tip, and I'm calculating the percentage of tip over here. I'm grouping by weekday and tip. So basically rather hour, I'm getting into weekday now. And now you can see Saturday over here as the best tip, that is around 8.22%, and then it gets lower to around 7% on Mondays, right? But there's not major difference, but still Saturday and Sunday as higher trip. So maybe people may more tip when they are not really at a more like vacationing or just sightseeing and everything. That's what we saw on the hour level also. People pay higher tip during the night time when it's non-office hours or non-working hours. And here also you can see when people travel on leisure, they tend to pay more tip. That's what it looks like as of now, right? And again, this we are just doing some analysis. We will still like in a data stage go and prod in my next video in future and see how really the graph looks like. But SQLs are pretty good to do analysis. Now let's continue. Let's go to little complex SQL statements. Okay, that's what we are going to see now. Now, one of the functions I'm going to introduce, there are a lot of analytical functions in SQL. Basically, there is like rank, there is some aggregation, lag, lead, there are dense rank, there are a lot of functions. The first function we are going to see, the lag function. Basically, the lag function is used to access data from the previous row. That's what the lag function is. This is a simple lag function that I'm going to put now. So basically, what I'm doing in this case, I have an inner query where I have data at the hour level, which you saw. Basically, at each hour level, I am calculating the average fare amount. But I want this fare amount, and I also want the previous fare amount next to it. Right. So that's what the lag function is used for. So I've just written a subquery over here. In the inner query, I'm just selecting the hour and fare amount. I'm grouping by hour. And in the outer query, what I'm doing is I'm taking this hour column that I selected, the fare column that I selected here, and I'm calculating lag of fare order by fare over here. That's what I'm doing. So basically what I'm going to doing is I'm just taking the previous fare amount over here. Yeah, that's what I am doing. So let me quickly run this and see the output. In this case, I'm using fare. I'm just taking the previous largest fare and then I'm putting it. But it can be anything. You can also do it on an hour basis or any other function. We will deep dive into lag function as we go into the details. This I just want to introduce lag function, and I will come back when I want to do more like seasonal aggregation and all in next few commands. Okay, just hold on. Now if you see the lag function, this is what it does. because since I'm doing a order by descending, let's come down. This is the first one, does not have a lag, so it's null. The lag value, the second column. But the later one, if you see over the 11.46 is migrated as lag value over here, and you have a new value. This one goes as lag value over here, and this is the new value of fare, right? So basically, what I'm doing, I'm also taking the previous row. The previous row can be any row, and I will tell you, it can be the previous row itself, or it can be 7 rows apart. If I want to do a basically, if you want to compare the current fare against the previous 7-day fare, then or previous last week Wednesday fare, then I can do that as well. That I will show you in some time. So this is how the lag analytical function works like, and you can use other analytical functions as well, like rank, to rank the top 3 fares, or rank the top 3 fares by category. So in the order by, there is also a partition by class where you can partition the data based on some window aggregates. Okay, but we'll talk about that. Now let's take a step back, and if you see, like, this is how our data was actually over here. Right now our data is at every second, but a lot of times when you develop an time series model, you want the data aggregated to be either at the hour level or day level, because we don't want too many data points sometimes, right? I have 8.8 million rows. If I start building a time series model with it, it's too much of data. Maybe I want to aggregate it at a day level and forecast at a day level rather than every minute level, because the pattern might change. So in that case, in pandas, typically we use a resample function. But how can we do that in SQL over here, right? So for that, what I'm going to do, let me go back to this query window, and let me kind of paste this query. So here what I'm doing is, I want to pick it up at day level. If you want to do at hour level, you can just change this to hour, or if you want to do at a month level, you can do it, change this to month. Now what I'm doing, I'm taking the pickup date time, which is still the second level. I am calling a function called date time underscore trunk, and telling trunk by day. So what it will do is, it will truncate the data at a day level, right? And then I'm doing a count of star. There is the count of star will nothing but be a number of trips per day. So if I want to resample the data, let me just put an alias to it so that it's readable. Yeah. So the only thing I'm doing is I'm resampling the data. So if I want to aggregate the data for my model at a day level, I can do that. If I want to do at hour level, I can do that as well. So if I run in this case over here, basically you can see the data is now at aggregated. You have only one data per day. Earlier, if you see, there was second levels. So for each data, what is the number of trips per day? Now you have lesser data as well compared to 8.8 million rows, because you aggregated it. So now you can feed it into your model. You can create a new table out of this. You can just do a create table, some XYZ as select star from, and you can do it. So this is where the resampling comes into play. There is one more important concept that we have in SQL, that's called common table expressions. Now, common table expressions, if you want to reference or join the same data multiple times, right? Either you can just create alias on the same table or do self joins, or you can use common table expressions, which are pretty neat way to do, right? It's kind of if code reuse, you can say about. So I will just introduce you to common table expressions, and then in maybe once I go into the detail, I will talk about where it is really helpful. So this is one example with common table expression. The common table expression, basically what you are doing is, you are kind of creating an in-memory table over here, and the syntax for that is with clause, and you're giving a name to it. So what it will do, you can just query this as a regular table. So in this case, I'm giving a name daily underscore trips, and then whatever we did in the last, we are truncating by day, and then I'm storing it within this clause called with. Now the daily trips I can just access as a regular table. I can access how much time ever I can just create an daily trip. I can union by some other filter condition in the where clause. I can do multiple things. So I create it one time and I can start reusing it. You can achieve the same functionality without CTE as well. Common table expressions are called CTE, but it makes your code more readable, and it's easy to understand, right? And in some cases, based on how you can cache this particular CTEs, you can get performance improvement as well, right? So let me run this. The same query, I have just converted that into an common table expression, and then I am just selecting from the daily trips rather than this data directly. So this is accessible. I can just call it multiple times as well. I can just do an union and again call the or union all and again call the same select star from daily trips for us, right? Now with CTEs, what I'm going to do is, let's see like how we can use CTE and lag together over here, and then we can call the previous day data rather than the previous time period data. How we can call the compare the current day number of trips with the previous week same day number of trips. That's what I'm going to do. So I'm going to use both lag function and the CTE function. So the if you see, the inner query is same that what we saw. We have at a day level data, and then we are counting the number of trips. That is the inner query. In the outer query, I'm taking the time, I'm taking the number of trips that we have, and I am calling a lag function where I am telling get me the number of trips from the previous seventh day, and I am ordering by time. So what will happen, the data is going to get ordered by time. So if today is 8th of yeah, April, it's going to go 7 days backward and pick data from 1st of April. So I'm comparing, if 8th of April is Wednesday, it's going to go previous Wednesday and get me the data. So I'm just doing a comparison on how week on week my sales is going, right? And that's what I'm doing over here. So all this is an common table expression. I'm getting the number of trips and the previous trips, right? And in the outer query, I'm going calculating the percentage, right? Like I'm selecting from this particular table. If you see over here, that's what I'm doing over here. Basically, I am selecting from daily trips over here, and then I'm selecting all the column. Along with all the columns are nothing but time, number of trips, and previous trips. The star will select all the columns, and I am adding one more column where what I'm doing is I'm taking the number of trips, subtracting by previous number of trips, and then multiplying by 100. This will give me the change percentage compared to the previous week. And in case if there is null in the data, then I'm just substituting with 0, and then that's it. I'm just printing it outside. Now once I run this, it's going to give me a side by side comparison of today's data with the previous day's data. Now if you see over here, now since I have given 7 days, the previous trip for first 7 days will be null because I don't have the lag value for it, right? And that's why the if you see the function, I just substitute it to 0. Now after that, it will give me, like in this case, 75 was the previous number of trip. It's giving me like 657975. So the change percentage in this case is 8000%, right? And similarly, if you go into the detail of it, you can basically see like, okay, there's a 9% change, there's a minus 1% change compared to the previous week same day. So this well, like lag can be used to if you don't give any value, it will compare always with the previous value. If you give a value, you can tell how much previous time period you want to go. Since I have already aggregated the data at day level, my previous time period is 7 days. But if you are not aggregating the data at the day level, it's going to go previous 7 time periods. So if you have a second level, it may go previous to 7 seconds, right? That's how it is, right? So here I have aggregated on the day. So this well, like your lag function can be used to get previous day data or the previous week data in time series. That is one other thing we typically do with time series data. That is, we calculate moving averages, right? So in the moving averages, typically what we do is we take previous 3 days data, we aggregate, we calculate the mean of the data and see how it looks like. Typically in stock trading and all, you have moving averages and exponential moving averages. I have a detailed video on that moving averages and exponential moving average in my time series course. You can click the link on the top and watch it, or I'll put it in my video comment as well to understand time series. So here what I'm doing is I'm calculating the moving averages. And for moving averages, if you see, my inner query is pretty simple. I have at the day level data, I have the number of trips, and in the outer query, I'm selecting all. Now I'm calculating the average number of trips. Okay, now this the second analytical function, right? We saw lag. Similar to lag, we can also use average. So here what I'm doing is I'm calculating the average number of trips, but I don't want, when I calculate average, it will give me a global average across all the record. I need to restrict it with some time period. So in this case, my moving average can be last 7 days of data. And that's what I'm doing over here. I am ordering it by time. I am telling rows between six preceding. So it will go six preceding is nothing but 7 days. So when you have 7 days, what you do is you go 6 days preceding, along with the current row, it becomes 7 days. Right. So I'm telling between six preceding and current row, do an moving average, and it will give me a moving average for 7 days. So when I run this, basically this average function is going to calculate average for the moving average for 7 days. So here, if you see over here, it's first is 75 because I don't have previous value. The next is I don't have 7 days because I have only 1 day. So it's calculating the average. So for the first, it will be 7 days or less. Okay, it's not exactly 7 days, it will be because we don't have previous value. But after the seventh record, it will always take the previous 7 days. It's like a sliding window that you do in time series analysis. That's what it is. You can similarly do exponential moving average or weighted moving average, whatever it is. There are multiple options available. Now, the other thing that is possible over here is basically, now what I can do is I can run multiple aggregate function. If you see, like typically when we take like an fraud analytics or customer analytics, we calculate like customer 6-day average, 12-day average, or 14-day average of a site visit, and other kind of features, right? Typically that's what we do, feature engineering. Now in this case, I am trying to do the same thing. So if you see over here, the inner query is same as the previous one that I explained. We have day level data and number of trips. This first one is similar. For 7 days, I am calculating the moving average. I am again creating the same function, but rather giving 7 days, I am giving 13 preceding and current row. It will calculate 14 days moving average. So in this case, what I'm doing is I'm calculating both 7 days and 14 days moving average. Now you can do it for 21 days, you can do it for 30, 90, 120 days and all, right? So in this case, if you see the output over here, it has given me both the 7 days and 14 days moving average. Until the 14 days, until the 7 days, both will be similar. But after 8th day, if you see, the moving average over here is different and here is different because it is taking more number of days than your 7-day moving average. Okay, so that's what typically we can use this to create multiple aggregate function over here. Now what we can also do is, rather than calculating average, if we want to calculate sum, right, we can also, I just changed this query without CT over here. I kept it very simple. So I just taking the pickup date time. In this case, I'm not aggregating by day. I'm going to take all the data. I have the fair amount. I'm just calculating a sum of last 30 occurrences or 30 time periods over here. So instead of average, I have sum over here. You can use any analytical functions. You can use sum. You can use, for if you have some other use case, you can use rank. You can use dense rank. There are a lot of analytical functions. Okay, so here I'm calculating sum of fair amount, and just I'm ordering by the pickup date time, and I'm calculating the previous 30 values. So what this will do is it will give me a running total of sum across the output. It's just going to, after like 30 days, it's just going to give me a complete running total. Not only 30 days, it's going to give me from beginning, but after 30 days, you can see a running total through the end of the record. This query is going to take little longer than the normal query. Yeah. Now if you see over here it's calculating the sum of these two value, sum of these three value and four, and after 30 days, basically it's going to keep moving the window. So on the 31st day, you will have 31 days of record, but it will go back, only take the previous 30 days. Similarly, when you go to 41st day, it is going to take the previous 30 days from the 41 day, not the entire 41 days. So it's kind of creating an rolling window, time series rolling window of 30 days. So these are some quick functions for time series analysis. There are a lot of functions. What I will do is, in this particular data set, these are the functions I were able to show. And again, this can run in against any database, Postgres or Oracle or any database. The queries are pretty much ANSI compliant, right? What I will do is I will try to take a different data set and go deep dive into some of the analytical functions. And these analytical functions are not only for time series. You can use order by any value, you can use partition by window function and all. I will talk about window function in my next video. But a quick way to analyze your time series data. Thank you very much.